Hello good people, I'm going to demonstrate how to convert an equation into a graph. I'm going to start by using the formula that helps us convert inches to centimeters. The number of centimeters is equal to 2.54 multiplied by the number of inches. In order to plot any equation, we need a couple of points. At this stage, you might be wondering, where are the points going to come from? None have been given to us. That is all right. We can generate our own points. And the way we do that is by creating a little table. I have selected a number of values for inches, not completely randomly. Essentially, I have gone for 1 foot increments. However, I could have picked any values. Using these values for inches, I'm going to calculate the corresponding values for centimeters by using the formula. The formula is telling me to multiply the number of inches by 2.54. I'm going to use my trusty calculator. I have 12 inches multiplied by 2.54, and it gives me 30.48. I can repeat this calculation for all of the values in the inches row. So I could go 24 multiplied by 2.54, and that gives me 60.96. Let me quickly complete this table. With the table complete, I have the ordered pairs that I can use to create my graph. Recall that the ordered pairs are the same as coordinates. So 12 and 30.48 will make a point, 24 and 60.96 will make a point, and so on. Inches will be on the x-axis and the centimeters will be on the y-axis. Now that I have the axes, I can plot the points from the table. And so I will have 12, 30.48, 24, 60.96, and so on. As I'm dealing with continuous numerical data, I can connect these points with a line. In a quick mid-video summary, in order to go from an equation to a graph, we need an equation, we need a table, and we need some points. We get the points by picking a few values for one of our variables, usually the x, and then calculating the corresponding values of the other variable, usually the y. In this second example, I'm going to look at the commonly used formulas for estimating ideal body weight. So in case of an adult female, the formula is 45 plus 2.3 multiplied by the person's height in inches minus 60 inches. And for adult males, the formula is very similar. This time we have 50 plus 2.3 multiplied by person's height minus 60 inches. As before, to create a graph, I'm going to start by creating a table first. I have picked 4 heights in inches and I'm going to calculate the corresponding weights. Let me deal with the data for adult females first. According to the formula, the ideal body weight is equal to 45.5 plus 2.3 multiplied by height, let's say 60, minus 60. And that will give me 45.5. I can repeat the same calculation for an adult female who is 65 inches tall. Now I would have 45.5 plus 2.3 multiplied by the person's height, 65 inches, minus 60 inches. I'm following the formula. And that would give me 57 kilos. So for each given height, I'm calculating the estimated ideal body weight based on the formulas given. Let me quickly complete this table. Now that I have my table, I have my ordered pairs. In other words, I have coordinates for the points that I need to graph. This graph is a little bit different from the ones I have used previously. It contains this zigzag break on the x-axis. This is known as a scale break. It is a discontinuity in the data. Why is it here? I did not have enough space to have intervals all the way from 0 to 80. The second reason, and it is very important in this particular case, is that the formula for estimating ideal body weight has a bit of a problem. it is only useful for adults who are taller than 60 inches. In other words, taller than 5 feet. The formula breaks down for anybody who is less tall than that. Suppose that we have an adult female who is 4 inches 7 feet tall. In other words, they are 55 inches tall. Let me use the formula. We will have 45.5 plus 2.3 multiplied by their height, 55 inches, minus 60. And that will give me an ideal body weight of 34 kilograms. That is not right. So once again, this formula only really works for people who are taller than 5 feet. And this is why I have placed this discontinuity. Using this formula and this graph to estimate the ideal body weight of anybody who is under 5 feet tall will give us nonsensical results. Alright, let me now plot my data. Based on my calculated results in the table, an adult female who is 60 inches tall would have an estimated ideal body weight of 45.5 kilograms. Somebody who is 65 inches tall would have an estimated ideal body weight of 57 kilograms. A height of 70 inches gives an ideal body weight of 68.5, and somebody with a height of 75 inches would have an estimated ideal body of 80 kilograms. As this is continuous numerical data, I can connect these points with a line. Now that I have plotted the female ideal body weight, I can do the same thing for the male ideal body weight. Let me do one more quick example. Here is a random equation that I have pulled from the depths of the abyssal pit. Y equals 10x minus 5. How can we plot this equation? As before, I'm going to create a table with a couple of x values. Here is my table, and now I'm going to randomly pick a few x values. Please note that they can be whatever you want them to be. However, to make things easier on yourself, pick x values in a sequence. In other words, something like 0, 1, 2, 3, 4, 5. Personally, I always like to have a couple of negative values. So here is my default choice for random x values. Negative 2, negative 1, 0, 1, and 2. Now, using the formula, I'm going to calculate the corresponding y values. When x is negative 2, I will have 10 multiplied by negative 2 minus 5. And that gives me negative 25. When x is negative 1, I will have 10 multiplied by negative 1 minus 5. And that will give me negative 15. Using the same process, I can calculate all of the corresponding y values. Let me do that quickly. And now that the table is complete, I have my ordered pairs, which means I can plot the points. Here are my x's, and now I can plot the points. When x is negative 2, y is negative 25. When x is negative 1, y is negative 15. When x is 0, y is negative 5. When x is 1, y is 5. And when x is 2, y is 15. And to make everything neat, I'm going to connect these points with a line. Once again, for those of you who have slipped into a coma halfway through this video, in order to go from an equation to a graph, we construct a table with a couple of values for one of the variables, usually the x, and then using the equation, we calculate the corresponding values for the other variable, usually the y variable. That is all for now, and I will see you on the flip side.